With Wacker's pilot coater, release coatings can be processed under realistic conditions. The results can subsequently be tested on site. Release coatings for self-adhesive labels, graphics products or industrial specialty products require individual solutions. The required backing materials, such as paper or film, obtain the necessary release and processing properties from silicones. Wacker can use its pilot coater to manufacture backing materials that can then be optimized to get the perfect result. Different backing papers and films can be coated with the individual silicone formulation or an emulsion. The prepared silicone formulation is poured into the coater. Alternatively, an emulsion can be used. Once the backing material has been inserted, the automatic coating process can begin. A film of silicone just 0.6 to 3 microns thick is applied to the particular backing material, paper in this case. The backing material is then fed through an air flotation dryer at a temperature of up to 200 degrees Celsius. The silicone is heat cured here. Alternatively, it can be cured in an upstream UV unit. The oven outlet is where the coated substrate is cooled and rolled up. Samples for assessing the quality are taken straight after. 4 standard tests can be performed on site. Measurement of the coating weight. Quick manual test for smear, migration and rub-off. Complete curing. Here, the preparation of extracts for further testing in a separate laboratory. And preparation for release value determination. To ensure the silicone coatings are always of optimum quality, Wacker tests every step of the manufacturing process in the lab. Various adhesive tapes or labels are stuck onto the backing material coated with the target coating weight, relamination, and test strips are cut out of the backing. The test strips are stored for 20 hours at a temperature of approximately 23 degrees Celsius between 2 flat metal plates or glass panes under a pressure of 6.87 kPa, 70 grams per centimeter squared. Alternatively, prolonged storage periods and, for accelerated storage assessment, elevated temperatures of 40 or 70 degrees Celsius in a drying oven can be used. This storage ensures good contact between the release liner and the self-adhesive material. The prepared test strips can now be tested by 2 methods. Slow peeling determines the force required to peel the release liner off the adhesive-coated face material. This simulates the peeling off of labels by hand. In this test, at an angle of 180 degrees and a peel rate of 300 mm per minute, the label or adhesive strip is peeled off the release liner. During this test, the force is measured continuously. The average value for each test strip is calculated from the intermediate range. Each test is repeated with 3 identical strips and the mean is determined. The high-speed peel test evaluates the release force of a label laminate at high release speeds typical of label manufacture, matrix peeling and machine labeling. This test likewise involves placing the prepared test strips in the measurement device. The high-speed peel test is performed at a specified speed. Average values can be used to evaluate the dynamic release process. Another test method is the stain test. This method is used to assess the coverage of silicone coatings. The test equipment is filled with an aqueous, ready-to-use dye solution. The coated paper is placed in a clamp and rotated by 180 degrees for a specified time, bringing the dye solution into contact with the silicone layer. If there are any gaps in the coating, this is where the dye is absorbed by the paper. A qualitative assessment of the coating can be made by visual inspection. Alternatively, a colorimeter can be used for a quantitative assessment. Where the coating quality is high, there should be hardly any visible staining of the paper, if at all. Release coatings require individual solutions that can be achieved by a specific test method to ensure a good level of quality. Adhesive release coatings have a diverse property profile that makes them the products of choice in many end applications. Precisely adjustable release forces and release force profiles, simple processing, flexible formulations, short cross-linking times, and extremely low migration values. Wacker, creating tomorrow's solutions.